Welcome. This is Algebra 2, 4.4. How do you find sums and differences of rational expressions? Now remember, rational expressions are any time that we end up with the fraction and the variable on the bottom. So that's a rational expression right there. Okay? So let's take a look at what happens with these. First off, we need to make sure that we're adequate at reducing or simplifying any of these fractions. And let's think back to when we did fractions. To simplify this, we would factor first. So number one is factor. So when we factor, 12 can be factored down to 2 times 2 times 3. 16, 2 times 2 is 4, times 2 is 8, times 2 is 16. Now anything that's alike top to bottom, we can cancel. We would get our factored form to be 3/4. That would be our answer. That's how we used to always do reducing fractions. Rational expressions follows that same principle. So our first step, factor. So 2x minus 8, if you think back to two-term factoring, what can go into both? We take 2 from both. So we write that out front, it would be 2. And then reduce that, it would be x minus 4. So there's our numerator factored. Now the denominator, it's a 3-term. So we would need to play the x game. 8 times 1 would be 8. Now if I have not shown you the shortcut on the x game, actually I'll use a darker pen than that red. If I have not shown you the shortcut on the x game, here it is. Since there is a 1 out front, whatever two numbers we find, those can go straight into our answer. Okay? So we look at it, what two numbers multiply to be 8? That would be 1 and 8 or 2 and 4. It's a positive 8. And so they have to have the same sign. 2 and 4 would add up to be 6. Now in order to be negative 6, they'll be both negatives. Okay? So negative 2 times negative 4 is positive 8. Negative 2 plus negative 4 is negative 6. We can go straight to our answers with those. So we have x minus 4, x minus 2. We cancel our like terms. Now, can we cancel the 2 and that 2? I hope you're saying no, and here's why. This 2 is a factor, it's being 2 times something. But this 2 is not a factor, it's being subtracted. So, 2 over x minus 2 is our final simplified answer. So now we want to try adding rational fractions. Let's go back and add fractions. Okay? When the denominator is the same, we just add straight across, so it would be 7/5. But the denominator has to be the same. So for example with these, denominator's the same. 4 plus, would combine our like terms here, this 4 and that negative 5, so it would be 2x minus 5 plus 4 be a minus 1. There's our simplified answer. Make sure you're copying down everything that I write on these boards and asking in class where I lose you. Be specific with your questions. Okay, so now we look at a fraction that doesn't have common denominator. First thing you would do in finding the common denominator would be, same as on the first board, factor. We want to know what our factors are when we're trying to find our common denominator. X plus 6 cannot be factored any further. There's nothing that we could pull out of those two. This other one, I'm going to erase that, get it in your notes. First step is factoring. We would play the x game. 1 times negative 6. Negative 6. So what multiplies to be negative 6 adds, well, because it's a negative 6, one has to be negative, one has to be positive. So they would be subtracting to make 5. Hopefully you said 6 and 1. Which would be the positive? The 6. The one farthest from 0 always matches the sign up here. And 6 is farther from 0. So now we take our shortcut. And we know that our factored form is x minus 1 and x plus 6. So our lowest common denominator has to contain each of the denominators. So in other words, for our lowest common denominator, we have to make sure that this denominator is in there and that this one is in there. So we take this one, I just take the larger denominator and write it into the answer. So it's x minus 1, x plus 6. Now I look and I see, is my smaller one inside of that? There it is. There it is. Okay? So all that we're going to do is make sure that if we had to multiply anything by our denominator, that we also multiply it by the numerator. So looking at this one, did we have to multiply anything by this denominator to get that? No. So we can just take our x plus 2 and move it over there. But for the other one, in order for x plus 6 to truly be equal to x minus 1 times x plus 6, we have to multiply it by x minus 1. What we do to the bottom, we have to do to the top, x minus 1. So we have 3, positive 3x, because we're just distributing. So we have plus 3x. 3 times negative 1 would be negative 3. Now, take your top numbers, the numerator numbers, and combine them. We have an x and we have a 3x, so we make that 4x. We have 2 minus 3 would be minus 1. And that is all over x minus 1, x plus 6. I do not ask you to multiply those back together, just leave them in factored form. Okay? So that's your final answer there. Make sure you're pausing and getting all this down in your notes. Now to find the difference, I give you an example of a fraction, like what you used to have, like in 6th grade. 3/4 minus 1 over 6. Again, we look at our denominator, we factor it down, and we see that 4 is equal to 2 times 2. 6 is equal to 2 times 3. So I come over here and I put 2 times 2 in the answer, and then I need to make sure 6 is in there. Because 6 is 2 times 3, I have to just underline, there's the 6, here's the 4. The only thing that I need to do on 4 is multiply by the 3. The only thing I need to do on 6 is multiply that by the extra 2. In other words, 12 is my common denominator. That's how you could find that. 2 times 2 times 3 would be 12. So 4 times 2, 4 times 3 equals 12. So I'd have to go 3 times 3. 6 times 2 equals 12. So I'd have to go 1 times 2. 3 times 3 is 9. 1 times 2 is 2. And then I just go ahead and subtract the top numbers and get my answer. So here's what I'm giving you with rational expressions. I have x minus 5 over x plus 2 and x plus 2 over x minus 5. Kind of a combination of confusing this if we get our top and our bottom too close. Okay, so the first thing we look at, let's get our common denominator. This can't be factored, that can't be factored, so we put them both over here. X plus 2, x minus 5. Had they been the same, then we wouldn't need to multiply them to get them to have a common denominator. So the x plus 2 has to be multiplied by x minus 5. So I'm going to set the x minus 5 right next to it. What I do to the bottom, I do to the top. X minus 5. So you would need to box that. Pause the video and box that. Okay, now x minus 5 needed to be multiplied by x plus 2 to get into the answer. So, for this one, I'm going to go x plus 2 is what I multiply by. We just write our denominator right over here, but on the numerator you need to box each of those. Don't worry about the minus between them. Pause the video, box them, turn it back on. Okay, now your answers there should have been, for x minus 5 times x minus 5, you should have gotten x squared minus 10x plus 25. And for x plus 2, x plus 2 times x plus 2, you should have gotten x squared plus 4x plus 4x. And that would be it. Okay? Now, we are subtracting. That's why I put the parenthesis around that, because you can either distribute the negative to all, or you can write this underneath the like terms and then distribute the negative. So I have x squared plus 4x plus 4. Now because I'm subtracting, I'm going to subtract each one minus x squared minus 4x minus 4. X squared minus x squared is nothing. Negative 10x and negative 4x would be a negative 14x. 25 minus 4 would be 21. So there's your answer. Make sure to pause, get it all down, and ask questions in class. So here's a real-world problem. We have miles per gallon fuel efficiency on the highway. We just label it as E. In the city, our fuel efficiency goes down 5 miles per gallon for that particular car. So we want to know what's the total amount consumed if you drive 25 miles on the highway, 10 miles on the city. Okay? So the way that we would do this is we say 25, oh, I don't like using red. Sorry. We'll go 25 miles on the highway. Our fuel efficiency is E. And then we're going to also be driving 10 miles in the city. So we're putting them together. And that would be E minus 5. So to get our total amount of gas consumed, we would just add together our miles per gallon divided by the, our miles divided by miles per gallon. You might be going, why are you doing that? Well, if you look at unit analysis, miles, we go 25 miles divided by miles per gallon, miles per gallon. Remember when we divide, we skip, flip, and multiply, so this would become times, and it would become gallons over miles, which means that our miles cancels, and it tells us how many gallons we're going to use. You can actually calculate out very precisely how many gallons you should have used if the car is operating how they sold it to you that it should. Or you can also calculate for a trip, upcoming trip, how much it'll cost you very accurately. Okay, so here we go. We see that we have different denominators. We have E and we have E minus 5. Neither of those can be factored at all. So our common denominator will be E times, E minus 5. Okay? Now, what did we multiply this by? We multiplied it by E minus 5. So we need to multiply 25 times E minus 5. This one, E minus 5, we're multiplying it by E, so it'll become 10E. So go ahead and distribute this, 25E minus 125 plus 10E. That's just our numerator. 25E plus 10E would be 35E minus 125. So now that we've figured that out, if you had the stats on your car, it would tell you what your fuel efficiency is, and you could actually just plug in what you're supposed to be getting, like 40 miles a gallon. You could plug it in for E, and you would know how many gallons you're going to be using. Okay, we'll catch you in class. Write down your questions.